Okay, let's just dive right in. You and I, we live in this world that's just completely run on data, right? But we almost never stop to think about the incredible, invisible engineering that keeps the whole thing from just collapsing into total chaos. So today, we're going to pull back the curtain and look at the amazing logic tucked inside a database like PostgreSQL, the stuff that's literally protecting our digital lives every single second. So what is it? What's the thing that's really standing between, say, your bank balance or that online order you just placed and just utter chaos? Because I'll tell you, it's not just about, sticking information somewhere. It's way, way more than that. It's about enforcing rules, making unbreakable promises, and, yeah, even surviving things that seem completely unthinkable. To really wrap your head around this, just imagine for a second, what if your bank account was just a number in a simple text file on some computer? Seriously. Imagine two bank tellers trying to update it at the exact same time. Who wins? And what about this? What if the power cuts out right in the middle of a transfer? Poof. That money could literally just vanish into thin air. That's the nightmare world we'd be living in without a proper database system. Okay, so the first line of defense against all that chaos, it's basically creating a super strict blueprint for our data right from the get-go. You can't just let people throw any old information into the system. You gotta define the rules right from the start. And that all starts with something called data types. It sounds technical, but it's a really simple but incredibly powerful idea. All that means is that you can tell the database, hey, this price column, it can only have numbers in it, and this name column, text only. Just by doing that, you wipe out a whole category of potential errors before they even have a chance to happen. All right, so the next layer of this blueprint is something called constraints. If data types are the basic building blocks, then think of constraints as the really strict guardrails for your data. These are rules that go a step further. They're not just about the type of data, but about making sure the data itself actually makes sense in the real world. And you can see here exactly how we build these rules right into the structure of the data table. See that primary key thing? All that does is guarantee that every single product has its own unique number. No duplicates, ever. And then, look at that check price greater than 0. That's a constraint, and it makes it physically impossible for someone to accidentally list a product with a negative price. The database itself enforces that logic. It just won't allow it. Okay, that's all great for single pieces of data. But what happens when one single thing you want to do actually involves multiple separate steps? Well, this is where things get really, really interesting, and it's where the database makes its most important promise of all. Let's go back to that bank transfer. Think about it. To move $100 from Alice to Bob, you have to do two separate things, right? First, you subtract $100 from Alice's account. Second, you add $100 to Bob's. But what if, and this is the scary part, what if the whole server crashes right after you take the money from Alice, but before you give it to Bob? Alice is out $100, Bob never got it. The money is just gone. So to solve this terrifying problem, PostgreSQL wraps the entire thing in what's called a transaction. You can see it here. It starts with begin transaction, and it ends with commit. You can think of this as a protective bubble that you put around the whole operation. It's basically you telling the database, hey, everything inside this bubble, it's all one single, indivisible thing. And this is the absolute guarantee. I love how the official PostgreSQL documentation puts it. It says a transaction is a single all-or-nothing operation. That's the key. Either every single step inside that bubble succeeds perfectly or none of them do. So if that server crashes midway through our bank transfer, the database just automatically rolls the whole thing back. It's as if it never even started. No money is ever lost. It's an incredible promise. So how does it do that? What's the magic? Well, it's this thing called the write-ahead log, or the wall. It's pretty clever. Before the database even thinks about touching your actual data, it first writes a little note to itself in this special log. The note basically says, hey, here's what I'm about to do. So if there's a crash, when the database wakes back up, it just looks at its to-do list, the log, and it can see exactly what it was in the middle of. It then makes sure that operation either gets fully finished or completely erased. Okay, so our data is safe, it's consistent, it's great. But there's another problem. What happens when your table doesn't have 100 rows, but 100 million or a billion? How on earth do you find that one piece of information you need without waiting, forever? This is where indexes become your best friend. Look, without an index, if you want to find a specific customer, the database has to do what's called a full scan. It's like trying to find a topic in a book with no index at the back. You have to read every single page from the beginning. It's painfully slow. But with an index, it's exactly like using the index in a book. The database just looks up the name, finds the exact location, and jumps right to it. It goes from taking minutes to being practically instantaneous. All right, so now our data is structured, its integrity is guaranteed, and we can find stuff in it super fast. We've solved a lot of problems. But what about the ultimate disaster? I'm talking about the entire server just poof, dying, gone. So, in any serious setup, you've got your primary server. This is the main one, the big workhorse. It's handling all the live requests from your application, all the reads, all the writes, everything. But it's also your single point of failure. If it goes down, everything stops. So, to protect against that catastrophe, you set up what's called a hot standby server. The best way to think about this is like an identical twin that's always shadowing the primary one. It's a live, constantly updated copy that is ready to jump in and take over at a moment's notice. And this whole process is called replication. This is the ultimate safety net. It's just continuously, tirelessly copying every single change from the primary server over to the standby in almost real time. So if that main server goes up in smoke, could be a hardware failure, a network outage, whatever, the system can automatically fail over. That just means the standby twin gets promoted, it becomes the new primary, and your application just keeps on chugging along. So when you put it all together, the crucial takeaway is this. A database isn't just some bucket you dump data into. Not at all. It's a fortress of logic. It's built with these blueprints that enforce structure. It has these thick transactional walls that guarantee every operation is all or nothing. And it even has this redundant design that means it can survive a catastrophic attack. And all this complex engineering is working silently, 24/7, just to create a digital world that feels completely seamless and effortless to us. It feels instant and reliable. And it really makes you wonder, doesn't it? What other amazing, invisible fortresses like this are humming away in the background, making our entire modern world possible?